Good day, Great Tolls, and welcome back to another lesson. And Great Tolls, as you guys can see, today is the 28th of December, a Sunday, and we will be tackling the sum to infinity of a converging geometric sequence or geometric series. This is all in efforts to just get the sequences and series topic done before the end of December. And yeah, let's just get started. So, boys and girls, a geometric sequence, as we said, yeah, a geometric series will converge if the constant ratio is between -1 and 1 itself. So, as you can see here in this big block that I've quickly highlighted and I've just summarized for us, when they ask you when a series will converge, you will always use the fact that R, being the common ratio, it has to be between -1 and 1, and that's when that set series will be a convergent series. Okay, now, boys and girls, a convergent series, boys and girls, we are able to calculate the sum to infinity of it. You know how in a geometric series, at times we can calculate the sum to, like, the sum of the first 150 terms. In a arithmetic series, we can calculate the sum of the first, I think, 1,000,000 terms. But what makes this different is that we aren't able to calculate the sum of infinity unless we meet a specific criteria, and this criteria means that our constant ratio has to be a value of anywhere between -1 and 1. And then we can be able to calculate the sum of infinity. Okay. And the formula for the sum of infinity, boys and girls, as we see here, is S of infinity is equal to A, whereby A is the first term over 1 minus R, where R is between -1, is of any value between -1 and 1. Alrighty. Now, boys and girls, we know that R cannot be 1 because that would then give us what? It would give us an undefined answer, because anything divided by 0 is undefined. Alrighty, boys and girls, let's just quickly get through this. Let's tackle questions whilst we're still at it, and then from there on, should you have any form of questions, please do not hesitate to let me know in the comment section below. So let's tackle question 1.1. Question 1.1 says, consider the following geometric series. 36 -18 plus 9 plus . So we're told that it's a geometric series. Okay, we're told, yeah, it's a geometric series, boys and girls. That being said, they say, why does the sum of infinity for this series exist? When will the sum of infinity exist? The sum of infinity will exist when we can therefore identify or prove that the constant ratio is of any value between -1 and 1. So let's quickly calculate the R value. Our constant ratio R is equal to T2 over T1, which is equal to -18 over 36. And if we can simplify that answer, -18 divided by 36, that gives us -1/2. Therefore, then you got there, therefore, the series has a S of infinity because the constant ratio is between 1 and -1. Okay. Then therefore can move on to the second question 1.2. It says calculate the sum of infinity. Okay, we said that the sum of infinity, boys and girls, of our formula is equal to A 1 minus R. So sum of infinity, we set our A value. What is our A value in the sequence? Our A value would be 36. Okay, so we put 36 here on top, and then from there on, boys and girls, what we do is we would say 1 minus, we would subtract our R value which we've calculated to be negative a half. So this would then give us, excuse me, 36 divided by, we know that when we have two negatives, we'll be adding, divided by 1.5, essentially. This sum of infinity value is equal to 24. And boys and girls, you can double check. Should you be finding different answers, just do let me know, and then from there on, we'll be able to work it out. So here it would be an easy 2 marks, and here it would also be a easy 2 or 3 marks when they happen to feel generous. Okay. Now, boys and girls, let's move on to question 2. Question 2 then goes on to this. It says, question 2, let's quickly see question 2. It says calculate. Just click on it, write it down here for us, because it says calculate. Here we go. Calculate the sum of infinity. Okay. Calculate where m is equal to 1 and it ends at infinity. So we can see that this is a sum of infinity, and we see that we're given a formula here. And when we're given the formula, it says negative 2m. That being said, boys and girls, I want us to just quickly, okay, m is equal to 1. That being said, boys and girls, I want us to quickly follow the steps that I've given you from the beginning. I do not want to repeat myself. I do not want to seem like a parrot, but we have to do this, okay? So where we see m, we'll start from 1, because this is where we start, okay? So it's 8 multiplied by 2, negative 2, 1, plus 8, 2, negative 2, 2, plus 8, 3. Excuse me. I apologize, boys and girls. 8, 2, negative 2, 3, plus 8, 2, negative 2, and 4. Now, we have terms we can work with. We're able to identify our a value and our r value by just quickly summarizing everything that's here. Okay, boys and girls? So, 8 multiplied by 2, all to the power of, let's just quickly put this in our calculator. 1 second, boys and girls. So 2 to the power of negative 2, 1 second, 2 to the power of negative 2. That would be written as an exponent. So essentially, boys and girls, we just have to apply our laws of exponents here, okay? So we'd have 8, and we'd have 1 over 2 to the power of 2, plus 8 over 2, 8 multiplied by 1 over 2 to the power of 4. Okay. Then plus, we'd have 8, 1 over 2 to the power of, what? 2, 4, 6. 6. Plus 8, 1 over 2 to the power of 8. Righty. And then from there on, that easily helps us. Okay. So that easily helps us, and I will just quickly plug this in to our calculator for us. I'll just quickly plug this into our calculator for us, and here then would end up having a 2, and then this strictly just give me 1 second, boys and girls. Multiply by 8. If you just further simplify this, you'd get this. 1 divided by 2 to the power of 6 multiplied by 8. That gives you an 8th, as we could see. And then from there on, 1 divided by 2 to the power of 8 multiplied by 8 itself gives us 1 over 32. Now, this being said, boys and girls, they said they wanted us to calculate the sum of infinity, okay? So we do have our a value. So we said that our a value, let me just quickly put it in color. A is equal to 2. R is unknown. How do we get R? We said we get R by saying, well, R is equal to T2 over T1, which is equal to a half divided by 2. If you want to use your mathematical thingy, you could just go like this. But remember, when we divide fractions, we tip in times. Therefore, we'd have 1, a half times a half, which gives us a quarter. Right. And you can easily put this into your calculator by saying, for example, T3 over T2. If you say an eighth divided by a half, an eighth divided by a half, which is 0.5, gives you also this R value. Okay, boys and girls. So I just went the long way, or I guess the mathematical route that makes sense so that you guys can understand where I'm coming from. Okay, so R is equal to quarter. So S of, they wanted us to calculate S of infinity. Calculate the sum of infinity. Right? Sum of infinity. But how do I know it's sum of infinity? Remember, boys and girls, what we said is, when they say they want us to calculate the sum, we say the top minus the bottom plus 1. So our n value, right? So therefore our n value would be our n value would be infinity minus the bottom, which is 1, plus 1. And these would cancel each other out. So our n would be infinity. Therefore, we are calculating S of infinity, boys and girls. So now what's our S of infinity? S of infinity is a 1 minus R. S of infinity is equal to our first term, which is 2. 1 minus R, what's our R value? Our R value is a quarter, boys and girls. So S of infinity is equal to excuse me, boys and girls, I'm just quickly having a tough time grappling with this calculator. Okay, so we'd have 2 divided by 3 over 4. S of infinity would be 2 divided by 3 over 4. And we know mathematically we tip in times when we have a fraction divided by another fraction. So we therefore then have what we call 2 over 1 multiplied by 4 over 3. As such, S of infinity is equal to 8 over 3. Okay, boys and girls, that's our S of infinity. I want us to then move on to the questions that follow. The other question, question 3. What does question 3 say? Question 3, boys and girls, is one you'd see in your tests a lot and in your exams. And it says, consider the following series: 3x plus 3x, x minus 2 plus 3x. So we have a series. So it says we have 3x. So it says we have 3x plus 3x bracket x minus 2 plus 3x plus 3x bracket x minus 2 squared, and it so goes on. And it says to us in question 3a, says to us, calculate or for which values of x will the series converge. Now, which values of x will the series converge, boys and girls? Remember the fact that I just told you. -1, or 1. So the constant ratio, a series will converge when the constant ratio is between -1 and 1. Now let's calculate, let's first get our R. What's the value of R? R is equal to, let's just say T2 over T2 over T1. Okay, so R is equal to T2 over T1, 3x, x minus 2, and then we'd have 3x. So therefore R is equal to x minus 2. This is our R. Okay. Now, that being said, boys and girls, R -1, 1. Therefore, R, when would this series converge? It would converge when R is more than -1 but less than 1. So therefore, plug R where you see R in this formula, because they wanted us to see where it would converge. X minus 2, 1. And we simplify. What you do on the left hand side, you do on the right hand side. So what I would do here is I would add 2, I would add 2, I would add 2, so that we can isolate x. And therefore, we would have here this side, negative 1 plus 2 is 1, x 3. So this series would converge when x is greater than 1 but less than 3. Okay, that's your first answer for this type of question. Now, boys and girls, let's move on to question B. What do we see with question B? Question B says, if x is a value for which the series converges, calculate the sum of infinity for which, okay, so it says, if x is a value for which the series converges, okay, calculate the sum to infinity of the series in terms of x. So calculate the sum of infinity in terms of x. Okay, sum of infinity, boys and girls, s is equal to a1 minus r. So what is our first term? This one is quite a straightforward one, boys and girls. Our first term is 3x because we're calculating in terms of x. So our first term is 3x over 1 minus r. We said that our r value is, what is our r value? We said our r value is x minus 2. So let's quickly try to simplify this, boys and girls. So we would have s of infinity is equal to 3x all over 1 minus x plus 2. S of infinity is thus therefore equal to 3x. There we go, boys and girls. 1, let's just quickly simplify everything. So we'd have 3 minus x. That's your answer. Okay, boys and girls. You'd get your answer there for substitution. And on this side, you'd also get your answer for just quickly working this out. So it's 3 marks. This would also be a good 3 marks if they're being generous. And yeah. And also, this question wouldn't be, question 2, for those of you that are asking, wouldn't be that much of a hassle also. It would also be a good 3 marks, if anything. Okay. Now, boys and girls, that's question 3. Let's quickly go into question 4. And then from there on, we should be done with the section, and we should be moving on to lesson 8, 9, and then 10 is just past papers. Now it says, the first term of a geometric series is 124, boys and girls. The first term, so they're saying they're telling us here, okay? So this is T1 is 124. The first term of a geometric series is 124. The sum to infinity is 64. Calculate the common ratio. What's a common ratio? The value of our common ratio is r. R is unknown. So let's write out a formula and let's quickly solve. Let's just quickly, there we go. Question 4. So the sum of infinity is given to us. Our a value is given to us, but we're looking for r. What formula would you be using? You would be using the formula s of infinity is equal to a 1 minus r, because we're missing one variable and they're looking for one variable. And boys and girls, we're saying that the first term is 124. Okay, so a is 124. Okay, and s of infinity is 64. Right. Now let's quickly solve for r. Okay, now boys and girls, we then follow normal algebraic procedures. So we can plug everything in. As of infinity 64. Our a value is 124 over 1 minus r. Okay, let's deal with each and everything accordingly. Multiply both sides by 1 minus r, and this side also by 1 minus r. Okay, and we would have 64 minus 64r is equal to 124. Now negative 64r is equal to obviously, what are we going to do? We're going to subtract 64 this side, and we're going to subtract 64 this side. And now we will have 124 minus 64, which gives us 60. So 60 would be this side. And then we divide by negative 64, and we divide by negative 64, boys and girls. And then our R value would find to be 16 divided by negative 64 is negative 15 over 16. Now, does this make sense? Yes. Why does this make sense? Because remember, okay, let me just show you the mark allocation. So you'd get a mark for solving, a mark for getting to R. So it's a good 3 marks, 2 3-mark question. But now, why does my answer make sense? So why am I so confident in my answer? I'm confident in my answer. I am confident in my answer. Why? Because I know R should be between negative 1 and 1. Is this between negative 1 and 1? Yes, this is less than negative 1. Perfect. Now, boys and girls, this was today's lesson, a quick, easy lesson, and we'll be continuing to the next lesson. And I should be done with the first topic of patterns, number patterns, and sequences. I've been trying to just not overload you guys with a lot of content. And in any case, I'm wishing you guys the best of the few days that you guys have left of rest. And yeah, anyways, guys, enjoy your days, enjoy whatever you're doing currently, enjoy your evening, whatever time you're watching, and all the best of your studies. I'll see you guys in the next video. Don't forget to like, subscribe.